Hi, welcome to 30 Minutes of Film, the perfect talk for 2020. It just about sums it up. I hope you're having a nice jfaill, or should I say jfaill. Hi,
My name is Roy.
my name
Wait,
is...
I thought we agreed that. No, don't. Wait.
That's better. Hi, my name is Roy van Rijn, and I work for a company called Open Value. And I'm running the Rotterdam The Hague branch, where we aim to be the best place for Java developers in the Netherlands. Back to you, Roy.
What? Why? Ah, man. Okay. Never mind, I'll start over. My name is Roy Braam. I work for a cool consultancy company called JPoint. I have also a nice announcement to make. But more about that later. First, start with a disclaimer. Assume all failures are made by us. We don't credit others. If you are convinced you are part of one of these failures, working in a project with us, don't worry, we won't mention your name. If you want any mental help with any of these failures, you can contact us on Twitter. Our DMs are open. So first start with a couple of failures with the only advice, just don't do it. No lessons learned, just don't make these mistakes. Or I hope you didn't make these mistakes. A very classic one, during my school period, I harvested bitcoins. I tried it out, just as a lot of people, I guess. And I had my wallet on my machine, probably worth a couple of cents, with a couple of bitcoins in there. And at some point I bought a new machine, threw away my old one, together with my wallet, and I could never restore them. But probably I could have bought a decent house here in the Netherlands if I restored them all. I guess more people made this mistake. Another one is that during my period at school, I had a side job where I was a system administrator, and I installed the Mailserver, which went pretty well. But I forgot to turn off relaying. And for those of you who don't know relaying, if you leave a Mailserver open for relaying, other people could use it to send their mail. And then it's used a lot by spam. And back in the day, spam was a big problem. We didn't have these kind of sophisticated spam filters. So after some time, 5 days or so, all big providers put our server on the blacklist, and it was not possible to send or receive any mail anymore because our server was blacklisted because of sending used by relaying. Too bad, just don't do it. Don't leave your mail server with relaying on. Another one is at that same side job, there was a new cleaner and we had a server room. There we had just a separate room with all servers in there and a mobile air conditioning unit in there to keep the warm a bit low, the heat a bit low. So I gave the new cleaner the keys to the server room and I let him clean the room, which went luckily okay for me because there was still a free power outlet where he could put his vacuum cleaner in. Imagine what happened if there was no power outlet and he just took one out, one of the servers, for example. Okay, don't do it. So, back to you, Roy.
Back to me? Wait, it doesn't say that in the script. Pass me the script. It does say so in the script. Okay, it's my turn. I want to talk about the use of proper tooling. At the Port of Rotterdam, we had a lot of microservices and they were communicating using IBM's MQ server. And we sometimes needed to access these queues to look at messages and maybe edit or delete some messages from a queue. And to use this, we used a very professional tool. You can instantly see the professionalism if you just take a look at this actual splash screen. It is a bad puppy production. It's called MQJ Explorer and it has a puppy as a splash screen. But the tool worked. It was not the best tool, but it was a working free tool which we could all use. we would click on the right mouse button, and then we, for example, could do a refresh on a queue, and then we could see the counter updated with the amount of messages on the queue at that particular moment in time. But in this pop-up menu, there's also a delete. And because this is a very professional piece of software, it's a bad puppy production. It won't ask you stupid questions like, are you sure you want to delete something on production? It would just delete it and throw it away. And this happened to me, and this caused an outage. And I wasn't the only one. It happened to colleagues as well. They would accidentally delete queues from production or mess up messages on production. The basic story here is, don't use improper tooling, or don't go cheap when you don't use cheap open source software all the time, especially not in this case where we have mission critical software that we're accessing from some cheap bad puppy production piece of software. It was just not the right tool for us. We should have known better. Back to you, Roy.
Thank you, Bottom Roy. The next failure is about stop tailing the logs. It was a cloudy Friday afternoon while we were deploying our microservice in a microservice platform called Pivotal Cloud Foundry. We deployed it there, we tailed the logs if everything was fine, and we do the tailing within the platform because the platform has a nice logging aggregator where we can see all the logs of all our microservices. So we checked all the log files, if everything was fine, and we continued the deployment, went to production, and we were done. Friday afternoon, another correct deployment on the Friday, so we were all happy, and we went to pack our stuff and on our way of celebrating a nice weekend. But then we looked at our monitoring screens, and at the monitoring screens we saw that there are 0 of our microservices running. So all of our deployed microservices were killed. That was a kind of weird. So we immediately went into the GUI, started them up again, and we saw that everything, all traffic was okay again, and we started investigating what happened. So this is our aggregator of our microservice logging, where we have a nice stop button. And that stop button is, of course, stop tailing the logs, right? Or is that button actually stop tailing the logs? We found out that we actually clicked the red one, so the stop service, which is not only stopping tailing the logs, but it also stops our services. Not one of them, all of them. So it stopped all our routing services. That was kind of shitty. So what did we do? First, of course, there was no confirmation screen like this, but the first thing we did was we requested a feature change in the platform. It was run by Pivotal Cloud Foundry, so by the Pivotal guys. We raised an issue and we said like, if you are really stopping a service, which is kind of important for us, maybe you should ask for a confirmation, because it can save people a lot of problems. We raised the issue, and after a couple of days they implemented it, the platform was updated, and we had this nice confirmation message. So that was nice. The other thing was that we actually are relying on a log aggregator within our GUI to verify if our service is healthy, which is not so well. So I think it's much better if you have a proper monitoring solution set up that you can see in one glance if your microservice or your service is healthy, and also during a deployment, maybe you have a separate deployment monitoring screen where you actually can see the differences between the old and the new version and see if your service is healthy and the deployment went well. Don't use your tailing your logs for it.
Thanks. The next failure I'd like to share is called a slow killer. At the Port of Rotterdam, we had an Angular application, and users were complaining that it sometimes caused the entire browser to crash. We didn't really take it too seriously though. how often does an Angular application actually crash a browser? So frankly, we didn't believe the users. And it took a couple of weeks for them to actually get really, really, really angry. And some manager type came in and told us, you have to fix this right now. Start taking them seriously because we're going to escalate everything. And it turns out this was a very long search. It took us weeks, maybe even months to find out what the actual problem was. And the thing here is, this isn't really a failure, a program. It's also a programming failure, obviously, but it's also a failure to actually find problems. So what turned out to be the case was there was a very small memory leak in Angular. When you create components, you can subscribe on services and streams. And if you forget to unsubscribe these things, there are references being kept. And this could be just a couple of bytes, a couple of kilobytes every time you click in the application. But eventually, these things will add up. And to fix this, the fix is very easy. In our case, we needed in the on destroy, we would unsubscribe. And there's even a better way to do this now, that is using the take until. This just uses a resource until the component is no longer needed. Very easy fix. What was the problem here? Well, it turns out a couple of things you need to realize. The first thing is that the clients, our users, were using an old desktop machine with maybe 1 or 2 gigabytes of memory. We are developers. We are using MacBook Pros, which has 16, maybe even 32 gigabytes of memory. We never experience these problems. We only test our application during the day. We don't leave it running for days on end. And even the desktop PCs could go 2, 3, 4 days without actually crashing with a out of memory. And on our machines, which had much more gigabytes of RAM, it would probably take a month of continuous running before our application would actually crash. So this made it extremely difficult to find this memory leak. The second thing, obviously, is the mismatch between client software and backend software. If this would have happened in a backend application, we would have seen the crash, we would have seen the log files, we would have seen an out-of-memory exception. We don't generally monitor or log our web application logging and output. So this is something to keep in mind, and this is also something that we changed to get a better feel for what's happening at the clients. So the first thing is profile your web applications. It's very easy to do profiling. Even the Chrome browser has a profiler built in. You can just go to the developer tab, and there is a performance and a memory tab where you can start a profiling session, and you can see all the allocations, and you can also find and discover objects that are not cleaned. So for some reason, it's very natural for us, if there's a memory leak in the backend, to fire up a profiler and find this memory leak. But I hardly see anyone do this in the front end. The second thing that could have saved us was to add proper linting. And this is something we did after we fixed the issues. It turns out in Angular, in your build pipeline, if you add proper linting, it will actually tell you you've subscribed and you forgot to unsubscribe to certain components. These two things combined will make sure this problem won't happen to you. Back to you again, Roy.
Thank you, Roy. The next video is about how we managed to get a complete banking environment down within 10 seconds after months of preparation. And we were not so happy. So the system I'm talking about is a platform environment that has multiple applications running on it. And it sends its log to a file where it's picked up by logging aggregators. But we also wanted to send it to a Kafka cluster. So with these events, teams could do whatever they want. They can listen on these events and get the logs by a event bus. We already used logback, and with logback it's very easy. It was our plan. We just add a socket appender Socket appender sends over the network to a server socket receiver, also from Logback, and that sends it with some network I/O as messages or events to a Kafka cluster. All very simple. So if you look at the Logback configuration, this is a normal SSL socket appender. We made ourselves a bit easier by implementing a custom SSL socket appender, and within that class we handled all the SSL stuff, so we don't have to do that with Logback configuration, but we had our own configuration for it, so that was much easier for us. But the most important thing for us was that it was asynchronous, because it handles a lot of requests and we don't want our application by sending logs be blocked, thread blocked. So we added a async appender. And with Logback also has a nice solution for it. You just surround your appenders, your socket appender, with an async appender, and it is asynchronous. So the platform we're talking about has more than 400 applications. It handles 3,000 requests a second. 150 plus teams are running on it. And it is synchronous servlet based, which means that we have a thread per request. So every request that comes in has a thread, takes a thread from the thread pool, and when the response is sent, the thread is released. So for us it was very important that the logging, also through network I/O, became asynchronous. Because if a network is slow, like for example takes 2 seconds to send the message to the server receiver from Logback, we keep a thread occupied for 2 seconds too long. So if it's all asynchronous, the threads will be offloaded and it will release the thread immediately again, and the log is not blocking all the threads. So that was nice. And because it's such a big application and a responsible application, because there was a whole banking environment running on it, we did a lot of tests. So we did breakpoint tests, we did high load tests, we did slow backend, no backend, failing backend, duration tests, performance tests, breakpoints. Like the code change was very minimal, but we took months to test it all the way through, so we were 100% sure that it will never block any of the threads. And actually, it ran quite well for months, actually. So we were super happy until one day, hell broke loose. While we were looking at our monitoring, we saw that all servers, like there were 60 plus servers, went down within 10 seconds. So they became unhealthy within 10 seconds. It was really causing a disaster because no one of the customers could log in anymore. Of course, all the transactions, etc., will be done, but all the web front from the banking environment was unreachable. So what went wrong? So we saw that at some point Kafka broke, which is okay. Kafka can break. Of course, our system shouldn't fail with that. So Kafka broke and it stopped actually receiving any more requests because Logback couldn't send any events anymore. So all threads got occupied and it stopped receiving requests. And while it was stopping receiving requests, we could also not send any more of these requests because the requests were not accepted anymore. So a timeout occurred and our threads were full. But we thought, hey, we tested this. If it is asynchronous, it should just work. So we looked at production, what is wrong there, and we saw this one. And for us, this one was easy because it's a template thing that we are actually putting our configuration in there, and it should look like this. But that was the wrong configuration, because this configuration isn't about asynchronous. This is just a synchronous socket appender. Although, while implementing this, we had a 4i principle. And we also had a 4i principle while doing the code change itself, because all our configuration was in Git. And we did multiple releases afterwards looking at these files and never saw any wrong thing. So although all the team looked multiple times to this configuration, we overlooked that we are in production running on a synchronous socket appender. So indeed, that makes it all explainable, because if Kafka breaks and if the socket receiver breaks, then indeed all threads are waiting because they couldn't deliver the message anymore. And because they're waiting, we didn't receive any requests anymore, and even the help point was not responding anymore. And because of the amount of requests, within 10 seconds, everything broke. So there's one single reason or thing we learned from this. Not everything needs to be configurable. Developers are sometimes stupid and they make mistakes. And making things unnecessarily configurable is like making a big sign with, "This is the place where you can make your failures." That's just wrong. If you don't need to be configured, don't configure it like it anymore. Back to you, Roy.
Okay. The next one is called cleaning up the log files. Often when we install software, it has some default logging, and we as developers are pretty lazy. We don't look at the default settings until it becomes a problem. And in this case, it was taking up too much disk space and there was no log rotation. So the tool in question, we changed the settings and we set the log rotation to 60 days. So after 60 days, it would rotate and it would not grow any bigger. This did leave us, though, with a couple of files from the previous years that needed to be cleaned up. And someone decided to write a small script for this. And the script looked something like this. We do a find on the current directory. In this case, this is a simplified version. In this case, we have a name, but in the actual case, we would find all the files that were older than 60 days. And then we would execute a delete. You can probably guess what happened here, but we're not that stupid. We actually came up with an idea, a 3-step plan. So the first step is to run this locally and to test that it actually works. And when we ran this locally on our machine, it deleted all the log files older than 60 days. So the second step in our master plan was to copy-paste the find part of this script and to run this on production. Just running the find part will just spool out all the locations of the log files that needed to be deleted. And then in the final step, we would run the actual delete on production. But seeing the title of this talk, this didn't quite go to plan. Actually, step 1 went perfectly. We ran it locally and it worked. In step 2, 2 tiny mistakes were made. The first mistake was, we are developers. You would imagine we are copy-paste champions, but in this case, the developer in question accidentally also included the delete part in the copy and paste. This wasn't what he meant to do, but it's what happened. But luckily, all our code is perfect, so it should not be a problem. It should just delete the files we wanted to delete. The second problem, though, was that the find runs on the current directory on dot. And in this case, the developer did it from the root of the file system. So instead of deleting all the log files older than 60 days, the machine started to delete all files on that machine older than 60 days, which included some core operating system files that it absolutely needed to run. So instantly, his terminal froze, nobody was able to SSH into the machine again, and yeah, it was pretty messed up. Luckily, though, there were backups. On a daily basis, a backup of the machine would be created. So we called our hosting party and we asked them, could you please restore a backup for us? And within about 10 minutes, we were back up and running. We wished, because We didn't. It took about a day. It turns out there were certain patches on the operating system that were not applied on the backup system, and it didn't work. We were unable to actually restore the machine from backup, and we installed a fresh copy and installed everything on this fresh copy to make it work again. It turns out that we did create all these backups, but we never actually restored the backups. And this, for me, is one of the biggest lessons learned. You have to test your backups. Because a backup that has never been restored is just as good as thoughts and prayers. It says nothing. And sure, if you think about, do we actually need to restore a backup to test it? Isn't that that takes a lot of time and it's pretty risky? But you can do this on, you can just redirect the traffic away from a certain node and test a backup there in a very controlled manner. The other option is to actually do this when the users are complaining that your system is offline, and you need to do this in a very stressful way. So that's not what you want. Please test your backups. Include this into your backup plan, and make sure they actually work. The second obvious thing is never paste scripts on production. After this, we started to limit the rights of the users to be read-only, to make sure people were no longer deleting operating systems on the server. And the second thing we did was sometimes we needed to do some scripts on production. What we did was we wrote them on our own machine, then we pushed them to Git. Someone else would review these changes on Git, and then on the production machine, you could pull the script from Git and execute it. So there was a lot less room for error in running actual scripts on production.
So what we learned the hard way, with the very expensive cost of making all these failures, is that it's good if you create a working culture where it is okay to fail. Because people will make mistakes. And they will fail. It's not a question if, but it's a question when. And if they happen, make sure that you are prepared. And don't let these failures become disasters. Make sure that you minimize the risks for these kind of disasters, to make sure that whenever people are making failures, you don't end up with broken systems.
One important thing, use proper tooling. Don't go cheap on tooling. Your hours and the hours of clients that are actually using your applications are far more valuable than some of the tools we decide not to use. So invest in proper tooling, invest in monitoring, in logging. It's worth it. Don't just profile your servers, profile your web applications too. This one is still often overlooked. They are turning into single-page web applications. They are full applications running for days on end sometimes. If you've got a memory leak there, it will become a problem. Use your backups. Actually test and restore your backups on a regular basis. Don't assume you've got a backup and it's working and you will be able to use it in case of an emergency. Restore them on a regular basis. Please make this part of your backup plan. Obviously, limit the rights on production. People should have read access to access logs, but that should be about it. Do things in an automated manner. Use Git for scripting, for example. Don't just type in commands. It's very easy to mistype stuff, to make mistakes. It happens all the time. And obviously use the 4i principle, especially on production. In our case, like I said, we're using Git for this. You push your change into Git, someone else reviews it, and then you are able to actually execute it on production in a safe manner. Thanks for coming here. Roy, thank you.
Thank you.
Please rate our talk in the official jfaill app. It was lovely seeing you all. If you've got any questions, don't hesitate and ask them. You're welcome.
There we are. I haven't seen a lot of questions in chat, but a lot of recognition, at least from quite some people. And a lot of thank yous, so that's good.
Yeah.
If people have any questions, then feel free to ask them in chat, of course. Personally, when I saw this presentation, one of the things that at least struck me as new is, which struck me is that most of the failures are about the peripherals of the system and not about the system itself. I don't know if that's a coincidence or what's your view on that? Is it the infrastructure of the system just too complex?
Yeah, I think things do become more complex. Of course, we all see that around us. But like we said in the summary or in the end sheet, is that it's okay to make mistakes, but make sure that these mistakes don't become disasters. People will make mistakes; they will do it every time again. It's not a case of when it or if it happens; it's when it happens, and just make sure that you take proper measurements to not make it as a disaster as the failures we showed you.
Mm-hmm. Then a nice question by Code Turk. Which one of the failures was the worst one?
Well, for me, the worst one was obviously the rm delete command one. First of all, it had a big impact. We were offline for almost a day. And second, it's just, you feel like an idiot. Like everyone felt like an idiot. So, yeah.
Yeah, for me, it was the moment that we had the banking environment completely down because imagine we knew the risks. We tested this like months. We really were prepared. And then at the point we came to notice that what kind of mistake we made, we were like, okay, we were like frozen for half a day because we were just flabbergasted by the mistakes we made.
Okay, nice. Other question by Peter. I was wondering if you could have seen these mistakes coming, but were there any warnings?
Probably, but we didn't notice. I hope, because otherwise it was a bigger mistake. Yeah, I think that's also the trick of learning from your mistakes. If you make these kind of mistakes, make sure that next time you'll be notified when you are making these mistakes, or actually before you make these kind of mistakes. It's not like going into a war room and fix that problem and then come out like a coding ninja and be all happy that you fixed the bug or the thing. Just make sure that you do something about it, that it won't happen again.
Also, if you can see a problem like this coming, then it's really bad, because then you should have fixed it beforehand. All these things, they happen to us because we didn't see them coming. Then we try to learn and make sure it doesn't happen again. Yeah.
A nice question by Marcel. Roy Squared. Generation after generation of developers make mistakes within languages, paradigms, frameworks, and toolings. What does a culture where it is okay to fail mean? Code reviews and local stage testing isn't enough, as you proved.
Well, one thing is we need to talk more about failures. If you go to a conference, everyone's talking about some big, cool problem they've done, and talks like this are rarer. They do exist, but yeah, it's rare. And that's the thing where you can learn the most.
Mm-hmm. Roy, maybe something to add to that?
Yeah, no, I do agree. Like it's like in a culture to be so super enthusiastic about the thing you did an awesome job on, but people forget about all these failures. And I think the most senior people made the most mistakes because they're for a while in this the type of work, so they know how easy it is to make big mistakes. But in general, yeah, we talk about it during a drink, but that's it, not during a presentation. So I think it should be done more.
Yeah, indeed, fully agree with that. Nice comment by Rule. Most mistakes these days are compound mistakes, right? The fact that you had to run that command in production was the solution to another failure.
Yeah, sure.
So it's not a single thing, indeed. It's very, very recognizable. And then the suggestion, let's all infrastructure as code, and this should be a mistake of the past, don't you think?
Well, it solves a big part of the problem is being solved. But another problem we had at the Port of Rotterdam was that we had Puppet running. And once in a while, it would visit our nodes and do something our supplier couldn't really explain. And it changed some things on the production nodes we didn't want it to change. So there was a whole new way to fuck up, basically.
Yeah, and it's easy also to roll out all your infrastructure as code, right? But you will roll it out over all your machines. So
yeah,
these mistakes.
They'll probably get bigger then.
Yeah.
More painful. Well, at least that leaves enough stuff for a new presentation on this topic.
For sure.
Okay, I don't see any new questions popping up. Oh, there is another one. How much fun was it to edit this talk?
It was fun recording it. It was fun coming up with ideas. It wasn't so much fun rendering it because I'm not sure if you could see it, but the video file was called Poging 5. So, yeah.
Yeah, we also came with this idea before the whole Corona thing. So we had great ideas, but then this came like, okay, how are we going to do this kind of presentation and not being together, etc. So it was fun making recording it.
Yeah, we had to upload the video a number of times to get it right, but in the end we were able to do that. Roy's getting a compliment at least on his beard. Assuming you wish, Roy. Nothing to comment on that. Exactly. Yeah, I was talking about you. Okay. Don't see any more questions coming around. If you guys want to add anything.
Yeah, I see one that asks like, "Hey, to do or fix me" mentioned in the. Thing. I actually once made the mistake that I sent I didn't want to set up a logging environment, so I used system out. And I used it in a very recurrent piece of code. And I wondered for half a day why it was so slow. And actually, of course, system out is not so. So it was actually kind of trying to debug it with system out, but it was not so handy.
Cool.
Okay.
Yes, it's actually even better. I actually knew someone who actually used that in production and just keep thinking about why his application crashed constantly. So I saw that one in production actually. It was a demo, but still.
Yeah, okay. Only got called once, right? So that's
it. Okay, a book called Checklist Manifesto said checklists could be used to prevent mistakes in operations and building. Could something like that work for code too?
Yeah, I done that. We had a checklist by deploying it manually, and then after 20 times deploying it, you think you know the manifesto, and you just leave it, and you're not doing it anymore, and then the whole thing comes over again.
Yep.
Yeah,
that's the whole problem with checklists, because every time a mistake is made, someone tries to capture it in a checklist, and then the checklist becomes 25 points, and then nobody wants to check the checklist because it becomes too hard, and then you ditch the entire checklist.
But you can, of course, create a checklist to follow the checklist.
Yeah.
Right.
So it's probably better to make sure these mistakes can't happen by actually fixing the underlying problem, because most of the things we talked about, there is an underlying problem in how you do things. Yeah. So it's probably better to fix those.
Yeah. And it's also great to laugh about your failures, at least if it's not a big disaster, of course.
Well, probably mostly after the fact, after some time after the fact.
Yeah, after some time, I guess, yes.
At least that was
just lay down. And...
Yeah. Very good. Okay, then I think that we're through with all the questions and also with all our time. Thank you, guys. Great presentation. And for everybody in the audience, hope you enjoy the rest of jfaill.
Yes. Bye.
Bye.